This lesson is 3.5, Triangle Inequality. The objective is, how do we apply triangle inequality rules? So the triangle inequality states that the sum of any two sides of a triangle will always be greater than the length of the third side. So the rule is segment AB plus segment BC will be greater than, the total of it will be greater than AC. So that is triangle inequality. So we have a question that says, can you make a triangle with the given sides? They gave us a triangle that has a side of 2, 3, and 1.5 centimeters in length. So the steps in order to do this, you would set up the three inequalities. Then the second will be determine if they are true. And third, you answer yes or no. If all your statements is true, then the length that they give you will give you a triangle. If any of them are false, at least one of them is false, then no, you cannot make a triangle out of the lengths that they give you. So I'm going to show you the first one. You set up two of the numbers, 2 out of 3 numbers, you add them together and make them greater than the third side. In this case, 5 is greater than 1.5, so it's true. You do another one, because there's going to be 3, you set up 3 inequalities. Second one, you add up one of the sides and another side, and then set it greater than the third side, which we had as 3. Notice that 3.5 is greater than 3, which is true. Then we do a third one, where we have 3 plus 1.5, and then we set it greater than to 2. Notice that you're changing the positions of each of the lengths that they give you to set up the inequality and to see if each of them are true or not. In this case, all of them are true, so then these sides, if they gave you this side, you can create a triangle, so your answer is yes. That is all you have to do with triangle inequality. They give you 3 sides, you do a combination of 2, add 2 of the sides and set it, and then make it greater than to one of the third sides. You switch the position around. If all of them are true, then you can make a triangle. If one of them is not true, then you can't make a triangle. So we have a few examples. For this one, we have 2, 3, and 6 inches. So the first one I added the 2 and the 3, and it's greater than 6, and made it greater than 6, and you notice that it's false. 5 cannot be greater than 6. So the next one, 2 and 6, greater than 3, 8 is greater than 3, yeah. And then this one, 6 plus 3 is greater than 2, yes it is. But look at this, we have false. It takes at least one false statement to make this whole thing not work for the triangle. So no, I can't make a triangle based on those lengths that they gave me, because one of the statement is false. If I did for the second one, I got 11, 12, and 15. 11 and 12 add up together, make it greater than 15, true. Then I put 11 and 15, add them together, greater than 12, yeah, true. Let's see if the third one will be true. So I use 12 and 15, add them together, oops, and made them greater than 11, and it is true. So these lengths that they gave me can make a triangle, so yes. And again, this is all about triangle inequality. You're given different combination, set 2 of the sides greater than to the third, find out if they're all true or not. If it's all true, you have a triangle. If one of them is false, then you can't make a triangle with those sides. All right, now there's another case where you find the measure of the third side of a triangle given the 2 sides. So in this case, we have to list 5 possible, list 5 possible lengths for the third side of a triangle that has a side of, oops, that one, side of 4 and 5. So the steps is you set up two inequalities. You solve for x, and then choose the numbers that will satisfy all the two inequalities, or supposed to be two, not three. So here's the work. So this is the first option. There's two options to do this. For the first option, what I did was I did x plus 4, and then greater than 5, and then I add up the two sides that they gave me and made it greater than x. So here I solved for x, and I found that x has to be greater than 1, and then for this one, 9 is greater than x. So that means whatever, and you put it in this state, that means x has to be greater than 1, but less than 9. So I know they said list 5 possible lengths. I list all of them that satisfy it, which is 7 of them, but whatever 5 would work. So from 2 to 8 would satisfy this inequality, would be an option for a third side for the two given sides that they list for the triangle. Second option, which is easier than doing this, remembering this, would be, let me make this bigger. The second option, you take the two numbers that they give you, you add them, you get 9, and you subtract them, and you get 1. Make sure your numbers are positive because we're looking for positive length. You're not going to have a negative 1 length for a side of a triangle. So second option, you take the two numbers that they gave you 4 and 5, which as you see, you add them, gives you 9, and then you subtract and gives you 1. So that means your numbers for your third side will have to be between 1 and 9, not including those two. So as you can see, you end up with the same numbers as we did when we did option 1. So these are the two different options in order to find the third length to make the triangle a triangle. So if anything, I think that you would be choosing option 2 because it's easier and quicker. Just add the 2 and subtract to get the two numbers, and then find the numbers in between to satisfy the third side for that triangle. Okay, so we're going to do examples based on that. They said the lengths of the two triangles are given. Find five possible for the triangle length. So we have 4 and 7. So we need a third length that will make this triangle a triangle. So I chose the second option that I did previously. I added the 2, 4 and 7 to give me 11, and then I subtracted 7 minus 4 to give me 3. So that means my value, which is I classify as x, will have to be between 3 and 11. Greater than 3, less than 11. So here are my options. And so it's more than 5, but 4, 5, 6, 7, 8, 9, 10 are my possible options for a third side for that triangle with these two given sides. Same thing with number 2, 6 and 6. I add them, I got 12, and I subtracted, I got 0. So that means my possible numbers has to be between 0 and 12. Greater than 0, less than 12. And here are my possible option for length for the third side. It could be any one of those. So that's all there is to it when it comes to inequality, triangle inequality. All right, so now triangle inequality statements. For this one, it says if one side of a triangle is longer than another, then the angle opposite the longer side is greater than the angle opposite the shorter side. And then they said if one angle of a triangle is larger than another, then the side opposite the larger angle is greater than the side opposite the smaller angle. What does that mean? So let's do the first one, talking about the triangle. If one side of the triangle is longer than another, then the angle opposite the longest side is greater than the angle opposite the shorter side. All right, so with the first one, they said list the angles in order from least to greatest. So in order to do that, we have to look at the sides. So we have 3.1, 13, 10.2. And actually, I'm going to make this neater by using the arrow. So basically, look at the numbers. Which one's the biggest one? So 13 is the biggest one. So now that means the angle opposite that is going to be bigger. And let's look at the next bigger size, 10.2. So that means the opposite is going to be the second biggest, which is A, and then this side will be the smallest. So let me use green. So if I were to do the sides, I'm going to put the sides from least to greatest. So the smaller side is 3.1, then it's 10.2, and then it's 13. Actually, I'm going to make this way. But since they want us to find the angles, to write the angles from order from least to greatest, so I'm going to put this blue from least to greatest. So for the angles, remember, the angle that's opposite the side would determine who's small and who's big. So I just put the sides because so that way I can visually see, okay, which side was the smallest, which one is the biggest. So since this side was the smallest, then that means the opposite angle was angle C. So C is the least. And then let's go on. Then the next one was 10.2, so the opposite was A. And then we have B. And I'm just going to, so it's least to greatest. So C will be the smallest angle, and B will be the biggest. This can be done without having any information about the angles. If you have the sides, it can determine which angle will be the smallest, which will be the biggest, because you're just looking at the angle opposite the side. Now for the next one, it says if one angle of a triangle is larger than the other, then the side opposite the larger angle is greater than the opposite side of the smaller angle. So let's look at the other example. It says list the sides. Well, I'm going to use another color. So we need to list the sides from the longest to the shortest. So we're doing from big to short. So first we need to know what the angles are. And I'm going to use, let's see, I'll stick with the black. So we know this symbol tells you that this is 90 degrees. And they already gave us 67. So you know a triangle is 180 degrees. So then you just do, you know that it's 180 degrees. This is 90. If you do 180 minus 90, then that means these two angles have to equal 90. So I'll just do 90 minus 67. And that will give me 23. And I'll put 23 over here. All right, so we've got the angles. Now we need to know which one is the smallest. But first, let me put the lines to show you that the angle, the side opposite the angle, will determine who's small, who's big. And then I'm going to do this. All right. And let me go back to, I'll do the sides first. So from, the angles. So it's from long to short, from big to small. So for the angles, this is just a reference for me to work with, so I know who's small, who's big. So the bigger angle is 90. So I'll put 90. And then the next one was 67, and then the next one is 23. Now they want us to find the sides and list it from least to greatest. So the one that says 90, I'm going to look at the opposite. So then that's my segment BC. Then the next one is 67. The one that's opposite is segment AC. And then the side that's opposite the smallest angle is angle AB. Side AB. And I'm going to box this because that's what they were asking us to look for. So BC is the biggest. Then the next biggest is AC. And then the smallest one, or the shortest, is AB. So that's it. I know with these problems, there's going to be some confusion because they're asking me for the angles. For this one, they ask you for the angles. They're not asking you for the side. When you see any numbers that is on the outside of the triangle, those are the sides. Do not represent the angles. You have to look at the angle opposite the sides to tell you if it's going to be big or small. And however the numbers are, if they ask you from least to greatest, you do it from least to greatest. If it's greatest to least, you do it in that order. Same thing with this one. If they're asking you for the sides, I don't want you to give me the angles. Sides and angles are two different things. So if they give you the angles, look for the opposite side of from the angle, and it will tell you if that side is going to be big or not. All right. Next one. Compare within a single triangle. So they say write an inequality statement to compare the specified angles below. So we have the first example. They give us this triangle. So what I'm going to do is I'm going to distinguish by giving them different colors. So this one will be the green triangle, and then I'll have a blue triangle for the other one. Right. So now they say compare angle ABD to angle BDBA. So angle ABD, I'm going to use blue for that one. So ADB, so this is this angle, and compare it to DBA. So I'm comparing these two angles. I'll color that one, and the other one will be an open angle. So if I look at it, there's no value for it, but they have sides. This triangle has 8, 10, and 12. So again, remember, we're looking at the opposite. Actually, yeah, I could use this one. Oh, that's too big. Let me go back. And I'll just go back to the regular arrows. So I'm looking at this, and then I'm looking at the opposite side. So I noticed that the opposite side of angle ADB is 10, and the opposite side of DBA is 8. So if I were to compare those two, I would say, good in spirit. Okay, so I'd say that angle ADB is greater than DBA because the opposite is 10 and it's greater than 8. So that's all you need to do is look at the triangle and then compare the sides or angles that they give you. And then they say compare, oops, this needs to get out, compare CDA to CBA. So that is the green triangle. I'm going to mark that. So CDA, oh, that's them together. I'll just make that whole thing the angle, and then CBA, and that's this whole thing. So they want you to compare that. So when you look at those two angles, the two angles, you have to look at the opposite side. So notice that you have these two, and then for this one you have these two. And let me see if I can make this bigger. Yeah, there you go. So when you compare those two, basically you're adding up the two sides. So for angle CDA, you add up 15 and 18, gives you 23, and then for the other side is 16 and 10, it's 26. So you can clearly see that angle CBA will be the biggest one. This is confusing because you're putting two different triangles, but it's basically an angle, and then you're just comparing the sides. So for this one, this is even more complicated. but just follow along. It says compare RSU. So RSU, let me mark that green. RSU, and compare it with angle SUR. So RSU has 5.3 and SUR has 5.2. So if we're comparing those two, we could say that RSU is greater than angle SUR because based on the opposite sides. And now we compare TSV, and then we compare it to STV. So the opposite side of that is 4.8, and the opposite side of this angle is 4.4. So if we were to compare the two, TSV is 4.4, the opposite side is 4.4, and STV is 4.8. So this TSV is less than STV. And then if you were to compare RSV, which is that whole angle, and RUV, you would have to add up the sides. And you can see that when you do add it up, you get 10. It would be less than 10.4. So RSV, you basically adding up the two numbers, and then you add up the other side. So RUV, adding up the two other sides, and you get your value, just like we did with this one, and then you can compare the numbers, and then you can determine the inequality. Okay, so we've reached the end, and just as a recap of triangle inequality, it just states that the sum of any two sides of a triangle will always be greater than the length of the third side. So that means it's the two shorter sides that you add up, and it has to be greater than the other side, the third side. And in order to find out if a triangle, you can make a triangle with the given sides, you set up the three inequalities. You do a combination of adding two of the sides and making it greater than the other one, and see if when you add up the two sides, it will be greater than the third. If it's all true, then you can make the triangle. If it's not, then you cannot make a triangle. And with an example where you have two sides and you need to find the third, there's two options. The one that is easier would be to add the two sides that they give you and then subtract them to find your range, and then all the numbers in between that range will determine your third side. And the triangle inequality statement, all it's telling you that if they give you a triangle with all the sides, the angle opposite that side will determine if that angle is going to be small or big. And if they give you a triangle with all the angles, the side opposite that angle will determine if that side will be short or small. So that's the triangle inequality statement with that. And that's the end. So this concludes lesson 3.5. See you around.